The midpoint M, of A, x1 y1, and B, x2 y2, is x1 plus x2 over 2, y1 plus y2 over 2. The distance or length of AB is the square root of x2 minus x1 squared, plus y2 minus y1 squared. Three vertices of parallelogram ABCD are, A1 3, B2 4, C5 6. Find D and the length of BD. Diagonals AC and BD share the same midpoint. The x-coordinate of the midpoint of AC is 1 plus 5 over 2. The x-coordinate of the midpoint of BD is 2 plus x over 2. They are equal. So x is 4. Similarly, the y-coordinate of the midpoint of AC is 3 plus 6 over 2. The y-coordinate of the midpoint of BD is 4 plus y over 2. They are also equal. So y is 5. Therefore, D's coordinates are 4, 5. The length of BD is the root of 4 minus 2 squared plus 5 minus 4 squared. It is root 5. The gradient of a line, M, is delta y over del 2x, or change in y divided by change in x. Given any 2 points on the line, the gradient, M, is y2 minus y1 over x2 minus x1. The gradient is constant for a particular line. Let's look at this right-angled triangle, where AB is the hypotenuse. Delta y, or y2 minus y1, is the height. Delta x, or x2 minus x1, is the base. The gradient, M, is height over base. If we take two other points on this line and draw a right-angled triangle like this, we can see that these triangles are similar. Therefore, the ratio of height and base remains the same. So the gradient of a line remains constant. Let's look at this angle in the right-angled triangle. We know the gradient is height over base. It is tangent of this angle. Therefore, the gradient of the line is tangent of this angle. Let's look at the angle the line makes with the x-axis. We see that it is equal to the angle in the right-angled triangle we just looked. Therefore, tangent of the angle of the line with the x-axis is also the gradient. The gradient measures the rate of change. The larger the gradient, the greater the rate of change in y. M is positive if the line tilts right. In the left graph, we see that both delta y and delta x are of the same sign. M is negative if the line tilts left. In the right graph, we see that delta y and delta x are of opposite sign. Therefore M is negative. The equation of the line is y equals mx plus c. M is the gradient. C is the y-intercept, because when x is 0, y is c. It is where the line intercepts the y-axis. If a point x1 y1 and the gradient m are given, we know m is y minus y1 over x minus x1. Multiply y minus y1 over, we get the line equation as, y minus y1 equals m times x minus x1. For example, if a line's gradient is 2 and it passes point 34, then the line equation is y minus 4 equals 2 times x minus 3. Rearrange terms, we get y equals 2x minus 2. If 2 points are given, we can calculate the gradient first. M is y2 minus y1 over x2 minus x1. And then we use the above equation with any of the 2 points. For example, if a line passes 1 2 and 3 4, we can calculate the gradient first. M is 4 minus 2 over 3 minus 1, which is 1. Then we use M with the first point 1 2. So the line equation is y minus 2 equals x minus 1. Rearrange terms, we get y equals x plus 1. The equation of the line can be also written as, ax plus by plus c equals 0. Find the equation of the line through the points 2 9 and 4 1. Give your answers in the form ax plus by plus c equals 0, where a, b, c are integers. M is 9 minus 1 over 2 minus 4, which is minus 4. Use the second point, we get the line equation as y minus 1 equals minus 4 times x minus 4. This is minus 4x plus 16. Move all terms to one side and the line equation is 4x plus y minus 17 equals 0. If two lines are parallel, their gradients are equal. If two lines' gradients are equal, the two lines are parallel. If two lines are perpendicular to each other, the product of their gradients is minus 1. If the product of two lines' gradients is minus 1, the two lines are perpendicular to each other. Let's look at this diagram. There are two right-angled triangles. Line 1's gradient m1 is a over b. Line 2's gradient m2 is minus d over c. These two triangles are similar. So a over b is equal to c over d. Cross multiply, we get AD is BC. Therefore, m1 times m2 is minus AD over BC, which is minus 1. Find the equation of the perpendicular bisector of the line segment that connects A1 2 and B3 6. The midpoint of AB, M, is 1 plus 3 over 2, 2 plus 6 over 2. This is 2, 4. Gradient of AB, M, is 6 minus 2 over 3 minus 1, which is 2. So the gradient of the perpendicular bisector is minus 1 over 2, which is minus half. The gradient is minus half. The line passes 2, 4. Therefore, the line equation is y minus 4 equals minus half x minus 2. In this class, we learned. Given 2 points, A, x1, y1, and B, x2, y2. The midpoint of AB is x1 plus x2 over 2, y1 plus y2 over 2. The distance of AB is the square root of x2 minus x1 squared plus y2 minus y1 squared. The gradient of line AB is y2 minus y1 over x2 minus x1. A line equation is y equals mx plus c. Given the gradient, m, and a point on the line x1 y1, the line equation is y minus y1 equals m times x minus x1. Given 2 points, x1 y1, x2 y2, find the gradient m first, which is y2 minus y1 over x2 minus x1. Then use either point to find the line equation. It is either y minus y1 equals m times x minus x1, or y minus y2 equals m times x minus x2. If two lines are parallel, their gradients are equal. If two lines' gradients are equal, they are parallel. If two lines are perpendicular, their gradients are multiplied to minus 1. If two lines' gradients are multiplied to minus 1, they are perpendicular.